Okay, this video is going to combine 9.2 and 9.3 together. 9.2 and 9.3 are both about the Pythagorean theorem, so we're going to look at everything that you can use the Pythagorean theorem to do and just combine it into one section of notes, and then you'll be able to do both assignments from 9.2 and 9.3. So this is your Pythagorean theorem. Okay, you have to have a right triangle in order for it to apply, but you'll see another situation where you can use it to help classify triangles. So the important part of the Pythagorean theorem is to make sure that you put the legs and the hypotenuse in the right place in your equation. Okay, so A has to be a leg and B has to be a leg. Now, it doesn't matter which order you put these in. I could have just easily called this leg B and this leg A. It's arbitrary the way you define those. However, the hypotenuse has to be C. So hypotenuse is the long side. It's the side across from the right angle. Okay, we say it's the side opposite the right angle. That is the hypotenuse, and that is the one that goes by itself in the Pythagorean theorem. So however long this side is, I'm going to square it, add it to this side squared, and it's going to equal this side squared. Okay, now there are hundreds and hundreds of proofs of the Pythagorean theorem out there. If we have extra time during class, I'll go through a couple of those with you. All right, so the Pythagorean theorem in right triangles, okay, is used to find missing side lengths. Okay, it's also always going to give you a true statement. Okay, so this will make more sense when we see the other ones, but in right triangles, a squared plus b squared equals c squared. Okay, and that'll make more sense when you get to the other ones. Now, a Pythagorean triple, this is some vocab that you're going to see. Pythagorean triple are a set of three numbers, set of three whole numbers that work in the Pythagorean theorem. Okay, so three whole numbers, so no decimals, no square roots, nothing like that. That satisfy the Pythagorean theorem. One example, the most common example, is 3, 4, 5. 3 squared plus 4 squared equals 5 squared. 3 squared is 9, 4 squared is 16. That equals 25, which is, of course, 5 squared. So 3, 4, 5 is an example of a Pythagorean triple because they're all whole numbers, and when I put them in the Pythagorean theorem, they work. Now, 5 has to be the hypotenuse, has to be C because it's the longest side. Always make sure you remember that. The longest side has to be C. Now, the Pythagorean theorem can be used for acute triangles and obtuse triangles. But it's not going to be used to solve anything in there, okay? It's going to be used to classify triangles as either acute or obtuse or right. So in acute triangles, a squared plus b squared is less than c squared. Okay? So the way to kind of think about this is, oh, actually, sorry, this should be bigger. Okay, so if my long side, this would be my long side, right? But it's not very long compared to these two together. So it's not spreading this angle out very much. So I'm going to get an acute triangle because when I square this value, I'm getting something that's smaller than these two things being squared together. So basically, you're going to have some kind of long sides. This is still going to be the longest side, but it's not extremely that much longer than these two together, okay? So that's going to give me an acute triangle. Now, the other case, a squared plus b squared is less than c squared. That means I've got a really big third side because it's bigger than these two put together, okay? And I'm squaring both of these. So think of it that way. I've got a really big c. Okay, and these are stretching to try to come together. Okay, they are coming together, but this is so long, it's really stretching out this angle and making it obtuse, so I get an obtuse triangle. Okay, so if you're trying to classify triangles as either right, acute, or obtuse, you're just going to fill out the Pythagorean theorem and see which case applies. If I get something on both sides that is the exact same, it's a right triangle. If the two added together are bigger than this one, it's acute. If the two added together are smaller than the one, then it's obtuse. Okay. The other thing to remember is your two small sides. Okay. So without squaring them, they have to add up to be bigger than your third side. If not, it's not a triangle to begin with. Okay. And this is something from a previous chapter that we learned. So make sure your two short sides always add up to be bigger than the third side. So let's look at some examples using Pythagorean theorem. Find the missing side and state if the sides form a Pythagorean triple. Okay, well, I have 11. This is going to be A. This would be B. I could just easily say that this is B and this is A. It doesn't matter, but this has to be my C. So I'm going to do 11 squared plus 60 squared equals C squared. Okay. I'm going to bring up my calculator here. Okay, I've got my calculator. So 11 squared is 121. 60 squared is 3,600. Okay, if I add these together, that's going to be C squared. So I'm going to add 121 to this. I get 3721. I'm going to square root that. I get 61. Okay, so C is 61. Now, if you look, I've got three whole numbers here, so this would be a Pythagorean triple. So another Pythagorean triple would be 11, 60, 61. That's Pythagorean triple. Okay, now let's do this one. Here's my right angle. Here's the side that's across from it. So this is C, this is A, this is B. So I need 2 square root 10 squared plus B squared equals C squared, so 15 squared. Now, when you see this, you're squaring this. And remember, squared is just taking it times itself. So I'm going to have 2 square root 10 times 2 square root 10. Well, 2 times 2 is 4. Square root of 10 times the square root of 10 is 10. Okay? So I've got 4 times 10, so this is 40 plus B squared equals 15 squared, which is 225. I need to subtract the 40 over to get 185. And that's what B squared is. Now, if I square root this, I get a decimal, which means you have to do your simplest radical form. You've got to break these down to find out what it is with the square roots in there. Okay? Because decimals are not going to be accepted in this chapter. So, let's see. This clearly divides by 5. It'll go in there 37 times. 37 is prime, 5 is prime. So this doesn't break down, so I would just have to leave this as the square root of 185. And that would be your answer. Okay, now this is not a Pythagorean triple because this is not a whole number, and that's not a whole number. So it's not a Pythagorean triple. Okay, so that's using Pythagorean theorem to find missing sides of right triangles. Now let's use it to classify some triangles. So first we want to figure out, can the lengths form a triangle? So I'm going to take the two short sides, add them together. 9 plus 17 is 26. Well, that's the same as my third side, and the requirement to make a triangle is that this has to be strictly larger than the third side. So this is not a triangle. Okay, if it was 26.00001, then it could be a triangle. But 26 being the same as the third side, what that would look like is, here's my third side, 26. These two other sides are only long enough to meet if they lay on top of that third side. Okay, so I've got no angles, I've got no separation between my sides, so that's not making a triangle, that's making a line. All right, here, let's look at this one. Does this make a triangle? 4 plus 9 is 13. That's bigger than 12, so yes. Now that I know that it's a triangle, I want to know what kind it is. So I'm using my Pythagorean theorem. This has to be B, A, B. The long side has to be C. So I've got 4 squared, which is 16, plus 9 squared, which is 81. And how does that relate to 12 squared, which is 144? Well, 16 plus 81 is 97. How does that relate to 144? Well, it's smaller than 144. So I've got a big long side, and then I've got two other sides that aren't quite making it. Okay, so this would be obtuse. Okay, and we can kind of draw this too. If I go over 1, 2, 3, 4, and then I go up 9, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and then I need something that's going to be 12. Okay, 12 on the diagonal is going to be long, so this one would actually make a right angle. Okay, so the only way these are going to meet is if you have to stretch that third side out. All right, let's look at this. So I have A, B, and C here. This is 10 squared plus 12 squared equals 15 squared. Well, not equals. We're wondering what it does. This is 100 plus 144. This is 225. This would be 244, which is larger than 225. So these two sides are pretty long, and they're coming together to be bigger than the third side. So this would be acute. So that's how you classify triangles as right, acute, or obtuse. Now, I didn't have any right ones here, but if I was given the side lengths 11, 60, and 61, and I plug those in the Pythagorean theorem, this is what I would get. I'd get 121 squared, or 121 plus 3,600 equals 3721. So I'd get this side equals that side, which means it would be a right triangle. Okay, so that's using the Pythagorean theorem, and in all the ways that you're going to be expected to know how to use it. You can now complete sections 9.2 and 9.3.